Yes, it's up. Alrighty. Yeah. So this webinar we mostly talking about C++, and going a little bit into common filters, extended common filters. Not really sure what I can explain for that. I'm going to give some pointers on that, just because there is a lot of content. I went through it, and I don't think I can actually describe it better than the course itself. So there's a few reasons why you need to learn C++. One being that it is very fast. It is a compiled language, therefore it'll be a lot faster than scripting languages like Python, which is being interpreted and then run. And the other thing is that it is very memory efficient. Bergeron has mentioned that it is still as memory efficient as C, or you can fit a lot of you can run a lot of C++ code on a very small amount of memory, which isn't it's not a necessity, but it's something to note. All right. So what I have here, so recently, uh, Jupyter Notebook has started supporting C++, and uh, I have installed this on my Windows subsystem for Linux. Formerly, some people would have known it as Linux subsystem for Windows. Um, Either way, and you can see it running here. So this one is running in this window. And I have followed this link here. If you'd like to explore C++ similarly with the way you export Python in a CLI or your Jupyter Notebook, you can follow this here. One thing I would say is something else that you have to do is export your Jupyter C++ locations, which I might not have mentioned here, but it's not a great big deal. You can just search it up and you'll be able to see it. One thing to notice with C++, in a lot of in a lot of the examples, for example, even Hello World, you won't be able to do this. You need a main program, the int main or return zero, whatever. With Jupyter Notebook, similar to with Python, you don't need a main. Well, with Python, you never really need a main, but you can do the same thing with C++ now, and you'll see that if I run this, it will say 123. This is I'm not sure if this is supported in any of these versions right now. We can try it and try to plus 17, right? And let's see what it does. No, this is I've explored the exporting modules um, and importing of modules. It doesn't seem to work with any of the C++ version I have right now. You can look into this if you want. Okay. The other thing I'd like to show is for C++ is um, how to use the debugging. One of the things you can do is you can add a -G flag, and there's a few other ones like which I will I'll send you a link after this. So unfortunately, with what I've been trying, it is only in one layer. Everything is in one layer, and it comes out the same. But if you have a program that runs through different functions, different classes, and things like that, um, it might not give you all the details you want. And if you add the -G flag, the debug flag, you'll get more detail. Okay. The other thing I've been doing here, what I've been doing here is I've been trying to create a static library. So one thing you will notice as you approach term 2, where you'll be reusing a lot of the you'll be using a lot of libraries like iPods and um, there's a lot of libraries for the highway driving project. A lot of those are static libraries. Some of them might be dynamic, but most of them are static libraries. Once you start exploring things like the what do you call that Carta simulation, uh, autonomous vehicle simulator, you might have to start messing with dynamic libraries. But right now we'll be showing about static libraries because they're more related with their development. So you can think of it like this. If you're working on a team and you are trying to share libraries that everybody can use. Let's say you have a function that you know that does the waypoint calculations, something like that, and different teams. Let's say the simulation team and the actual self-driving team is using the same thing. It makes sense to share it via library rather than copy paste, right? And there are ways to do this. So I follow a simple tutorial which I will be sharing after the video, and but you can see that here that I have a mathematic function, C++ a header. So these are some of the outputs. I have the first output. So this is just a build from the CPP, and then this is the static library, and of course this is the output for the main. I don't exactly remember syntax because I'm still new at this, so I will use the aid. Okay, so first we use Z++ minus C. So minus C is essentially saying do not attempt to link. Um, So this is essentially creating a standalone library. Right. So this will actually generate. Here, let's just do something. Let's clean this up. Remove start.o. So anything with no, anything with yeah. Okay. So let's see what's left. Let's remove all the my SOs as well. I can also remove the out. Okay. So if I run the same command as before, right? This will create my the mathlibs output here. And essentially the second step is to create a static library, which is this command here. You do pass a minus shared and and make sure the output is ensign.so. There's something mentioning here that the lib, this is a convention, and you'll see how this hides this lib later on. And so this creates the static library with the name libmymath.so. So now we will try to build build using this. So there's a problem here because as you can see, it can't find my mask lib because it is trying to look in a default location, and it's somewhere in user/bin. But there is a way to get around this, and the suggestion here is that you can supply where you can find the library. Right. So you can see one thing I'm not quite sure what -val does. I believe this is not really necessary. Yeah, it's the same thing without the -val. I have tried. I did some search. Still, I can't quite find what -val means. So here you can see that the first one is to tell you where you can find the library is at, and where your second part is essentially telling you where the your main modules, which is main SCP or whatever else you're trying to link or build to here. And again, I believe we don't really need the -val. So I run it again without the -val, same thing. And let's see. And now you can see the a.out has been generated, and we just do. Oh, whoops. There's something I forgot to do. I never did clean up main.cpp. So I'm trying to simulate a row, see if I can add more details by adding the debug flag, but the situation was too simple for a debug flag to show more details, so I decided not to showcase that. Let's just start this again. Actually, I believe we can just start here, right? So because the shared library has already been out, it doesn't need to be. You don't have to link it. You have to rebuild it again, and just read that out. And that just says 5 plus 7 equals 12, which is the main. It is using the make functions, which is part of the math function namespace, and this is coming from, let's see, at right. So this is just add from here, and you see my math function here, and this returns that. Okay. Right. So yeah. And I think that's it for some of my some of the additional showcases here. We can let's get some pointers on the project itself. One good resource is that you can always go to discussion here. And this is what I have been using for any of my questions. And let's see, for the categories. And that sounds not helpful. Courses. Let's go under courses. So you should be able to navigate to. Really? Oh, it doesn't count as a course. Interesting. All right, in that case, I will have to help you find that. It seems it would appear that okay. it have appeared that okay, it would appear that the united form has gone unkept for some time, and things has started to become harder to find. And therefore, I will be helping you hunt down where extended common filter is here, and I will be sending that as a link. One thing to note about the extended common filter is that the way to approach it is to first go through, I would say, one, either the LiDAR or the radar sensors, and have the vehicle do the detection there. I would say start with LiDAR because LiDAR is the simpler of the two, and then move on to radar. And as you start using the radar measurement, you do have to be careful as you go through the circle. As you know, the circle goes in like a figure eight, and as you go over the arc and as you go up the arc, there will be some difficulties because you are using the arc10 function. I remember having difficulties with that myself, but just remember that it's kind of to be expected, because we are not, we have been, most of us have been away from mass for quite some time. If we run into issues, you can refer them to me, or you can look at the discussion here. And as far as these as webinar goes, this is the last course related webinar. From here on, the next two will be focused on student work. So if you have any questions regarding project 5, I believe, in term 1 or any of the previous projects, you can direct them to me, and I will bring them up as a webinar. Or of course, you can always request one-on-one, or just directly directly contact me on Slack. But either way, I will be happy to bring up your questions in webinars, as I have done the previously ones, because I do feel that especially the later projects, they are of increasing difficulty, and it does good to have student to have overview of students' questions. I think that does it for today, and I'll be seeing you later.